Okay, this is lesson 14.1, which is on page 628 in your textbook if you are following along. And it starts out, we're talking about square roots. A square root of a number is a number that when multiplied by itself equals the number given. Every positive has a positive and a negative square root. A perfect square is a number with integers as its square roots. Okay, so let's make sure that we understand what's going on there. Hopefully you know you've seen a square root sign before that's called the radical sign. It kind of looks like a check mark combined with a division sign. Okay, and we call that the radical sign. So it says here, example 1, finding square roots of a perfect square. So find the two square roots of 49. Well, we know that 7 times 7 is 49, but we also have to remember negative 7 times negative 7 also equals positive 49. So there are two different numbers that when multiplied by it themselves, so 7 times 7, or 7 squared, is 49, but negative 7 squared is 49. So the square roots of 49 are 7 and negative 7. Now that doesn't mean you multiply these two together to get 49. It means you square 7 to get 49, or you square negative 7 to get 49. The symbol here is called the radical sign. It is used to represent a square root. The number under the radical sign is called the radicand. You won't have to remember that, but it is called the radicand. You might have to remember it later. So if we just see the radical sign here, for instance here, square root of 16, then we are only looking for the positive square root. Okay, so we're normally looking for the positive square root. Up until now, you've probably seen the radical sign before, not maybe known what it was called, but you knew you were looking for the square root of something, and you probably always just thought of the positive. What's the square root of 25? 5. What's the square root of 100? 10. And you never thought about making the negative. That's okay, because if we look at it like this, we're just asking for the positive square root. If we put the negative sign out in front of the radical sign, then we are looking for the negative square root. So the negative square root of 16 is negative 4. And if we want both of them, we'll put this little thing out here. It means positive and negative. So we want the positive and negative square roots of 16. And you could put positive 4 and negative 4. But if you wanted to, you could also put that little sign out there, which means the positive or the negative. So you've got that little sign out there, which means both 4. I don't know how much really time that saves you. 1/4 of a second or something like that, but you do that a million times and then that's 250,000 seconds you've saved, so yay. Example 2, finding square roots. So find the square root of 25. Because there is no negative or that positive negative out here, we're just looking for the positive square root of 25. And because 5 squared is how we get 25, the square root of 25 is 5. Okay, so here it says now we're looking for the negative square root because it's got that negative sign out front. The square root of 9 over 16. Well, 3 over 4 times itself, because we remember when we're working with fractions, we multiply across the top to get the new numerator. We multiply across the bottom to get the new denominator. So 3 times 3 would give us 9, and 4 times 4 would give us 16. So it's 3/4 times 3/4 is how we get 9/16. Therefore, the square root of 9/16 is 3/4. And because we have that negative sign out front, we're looking for the negative square root, so it would be negative 3/4. And then finally, we can also do this with decimals. Here we're looking for the positive and negative. So when we're all done, we'll make sure we have the positive square root and the negative square root. And 2.25. Well, because 1.5 times itself gives us 2.25, then the square root of 2.25 is 1.5 and negative 1.5. A good rule of thumb here is when you have two decimals, 2 numbers behind the decimal, your square root will have to have 1 number behind the decimal, because when we multiply it by itself, the multiplication rule when we're multiplying decimals is how many numbers behind the decimal up here equals how many numbers behind the decimal in the answer. So 1 for each of these would give us 2 for the answer. So when there's 2 numbers behind the decimal in the number under the radical sign, you'll have 1 number behind the decimal in its square root. All right, well, let's work on a couple of these. Find the square root, and it says find the 2 square roots, which means they want the positive and negative of the numbers. So for number 1, I'm going to write square, and I'm going to put the positive negative out here. So find both square roots of 36, and we know that 6 times 6 is 36. So to give both square roots, I'll put positive and negative 6. For number 2, the both square roots of 100. Well, we know 10 times 10 is 100, so this time I'm going to write it this way. I'll write 10 and negative 10. Number 3, positive and negative square roots of 121. Hopefully we know 11 times itself is how we get 121. So positive and negative 11. Now it just says find the square maybe roots. Here we're looking for 2, so that's why the S is in parentheses. But here we're only looking for the negative square root. So for number 4, the negative square root of 1, well, 1 time, that is one of the ugliest radical symbols I've ever seen, but that's okay. We can see what it is. The 1 times itself is how we get 1. So we're looking for negative 1 there. Okay, negative because we have the negative sign out front. Number 5, positive and negative, so both square roots of 4 over 25. Well, what times itself gives us 4? 2. What times itself gives us 25? 5. So 2/5 times 2/5 is 4 25ths. And we're looking for both of them. So 2/5 and negative 2/5. And finally, number 6. Now it doesn't have a negative out front. It doesn't have both symbols out front. So we're just looking for the positive square root of 12.25. Because there are 2 numbers behind the decimal here, I know there will be 1 number behind the decimal in my square root. Now I don't know what the square root of 12.25 is, but I do know that 3 squared is 9 and 4 squared is 16. So it's going to be somewhere between 3 and 4. So I'll just pick right in the middle and see if we can narrow this down. 3.5 times 3.5. 17, 0, 15, 9, 10. Awesome. It is 3.5. So the square root of 12.25 is 3.5. And they were only looking for the positive, so we just leave the positive. Example 3. Example 3, evaluating expressions involving square roots. So now we've got some expressions here where we use the order of operations. Remember, we do parentheses first, then we do exponents, then multiply and divide from left to right, and then add and subtract from left to right. And really it's like, well, when do square roots come in here? Because I didn't hear square roots. Well, squaring a number, or to the second power, is really the opposite of square root. And so we do parentheses, which means all grouping symbols. And then when we do exponents, it also includes doing square roots or cubed roots or any other kind of roots. So right now we're just talking about square roots. So it's actually in the second step of the order of operations. So let's look at this. This example 3a, when looked at correctly, so this is 3a, is 5 times the square root of 36 plus 7. So there's no parentheses or grouping symbols here, so we go right to exponents or the roots. So the square root of 36 is 6. This now becomes 5 times 6 plus 7. Obviously, we do multiplication before addition, so this would be 30 plus 7, which is 37. Oh, they got it right. Good for them. 3b, 1/4 plus the square root of 18 over 2. Well, we can simplify this, and 18 over 2 is 9. So that's really kind of a grouping symbol under here. Now I've got 1/4 plus the square root of 9. Now I do the root. We know 3 times 3 is how we get 9, so this becomes, 1/4 plus 3. And 3 plus 1/4 is 3 1/4. And then example 3c. And here we have the square root, 3c, square root of 81, but then we have that squared, minus 5. Well, if we take the square root of a number, whatever that number is, and then immediately the next thing we do is square it, we're really just going to get back to that number. For instance here, the square root of 81 is 9, and then 9 squared is 81. So these are inverse operations, and they cancel each other out, the square root and then squaring. Or you can take them one step at a time, it doesn't matter. But the square root of 81 is 9, and 9 squared is 81. So now those two cancel each other out. We're left with 81 minus 5, which is 76. Very good. Here are some on your owns to work on for us. Number 7. 12 minus 3 times the square root of 25. Well, the square root of 25 is 5, so this becomes 12 minus 3 times 5. Multiply first here. 12 minus 15 equals negative 3. Number 8. The square root of 28 over 7 plus 2.4. 28 over 7 is 4, so this becomes the square root of 4 plus 2.4. The square root of 4 is 2, because 2 times 2 is 4. So the square root of 4 is 2 plus 2.4, and that equals 4 4/10. And number 9, we'll put right over here, 15 minus the square of the square root of 4. Well, if I take the square root of 4 and then immediately the next thing I do is square it, I'm just going to get back to 4. If you wanted to take it one step at a time again, square root of 4 is 2, and then 2 squared is 4. So either way, we get back to 4. This becomes 15 minus 4, which is 11. Number 10. The area of a circle is 2,826. I don't feel like doing that one. And let's just look at 3 of the exercise problems from page 630. I like these 3 problems right here. Number 4, if the area of this square is 441 centimeters squared, so we know the area of a square is length times width, but because the length and the width are the same thing, we can also say the area of a square is just the side squared. We also know that when we square that side, we get 441. So we have to think what times itself gives us 441. And so we take the square root of each side. Take the square root of each side, and we get S equals 21. So in order to get the variable by itself, it was S squared, I have to do the inverse operation. And the inverse operation of squaring a number is doing the square root. I can't just do the square root to this side. I have to do the square root of each side. Okay, so kind of like when we multiplied or divided both sides by the same number, added or subtracted the same number to each side. Now, if we have the square of the variable, we take the square root of each side over here. And we couldn't, so number 5, same kind of thing because it's a square again. So we'll say side squared equals 1.69. And we know that the square root of 1.69 will have to have one decimal point or one number behind the decimal because the square of it has two numbers behind the decimal. So square root of S squared and the square root of 1.69, S equals, well, I know 13 times 13 is 169, so 1.3 times 1.3 is 1.69, and this would be kilometers. It was kilometers squared when it was area, but now we're just doing one side. Or we're taking the square root of kilometers squared, which is just kilometers. This one should have been centimeters. Number 6, the area of this circle is 64 pi inches squared. Well, we know the area of a circle is pi r squared. So now we also know the area of this circle is 64 pi. So what do? Well, let's start by dividing each side by pi. And we can get that out of there. Well, that's nice. It canceled out on both sides, leaving us with what? R squared on this side and 64 on this side. I think you can see where this is going. We take the square root of each side. R squared, the square root of this. The square root of this. And the square root of r squared is just r. And the square root of 64 is 8. 8 what? 8 inches for the r radius. Okay, so nice problems. There's one like this one on your homework, the last one, number 10. So you can do a couple of these. The odds here, checking the answers in the back of the book, of course. These are pretty quick and easy, I think. And then you'll go over and you'll do journal page 328 for lesson 14.1.